Welcome to episode 10 of the SoothSight podcast and part 3 of my 4-part interview with Dr. Lloyd Colegrove, recently retired data science leader from Dow. In this episode, we discuss topics such as digital twins, the evolution of AI and chemicals, and problems that AI vendors face when working with big chemical companies. If you missed parts 1 and 2, make sure to check those out as we delve into interesting topics like interdisciplinary collaboration between AI practitioners, engineers, scientists, and stakeholders, as well as the importance of having humans in the loop, constraints and challenges specific to chemicals and manufacturing, bottlenecks to success, particularly tricky problems, real-time analytics leading to more proactive and productive manufacturing, and where AI is particularly useful in plant operations. With that said, thanks for tuning in and enjoy.
How do you feel about digital twins? Are you skeptical or excited? Do you see it as the future?
Well, I was excited about digital twins when I first heard about them in 2015. So my understanding of digital twins today and how they're being used is they would give us a much greater insight into how a plant actually operates, which is valuable to the operators and the engineers that we bring into the plant. I was in Germany at the Fraunhofer Institute in around 2016 to 2017, and they had a digital twin operating a distillation column. And they had a 3D rendering that you put these glasses on, and there the thing is operating. But instead of it being a silver coated cylinder in a plant, you could actually see flows and temperatures and product moving in the distillation column. And if you leaned into the image, you could actually see it working. I mean, inside, you could walk inside the distillation column. Now, that's cool, and it has great training opportunity. But you know, the engineering tools that my process and design engineers use to design a chemical plant are very capable of doing the design. So the tools are already out there to do everything we need to do. What we need is better tools to educate the users of that result, the engineering and the process and the chemistry. And then the digital twin can also, again, like I said, AI be very handy in helping us perturb the plant to see what kind of responses we get. And then if we see certain unique responses, we start looking for those data signatures in the real plant and know what's going on, right? Because once you see the same data signature, you can go back and figure out if they are indeed the same phenomenon. The digital twin concept has stalled, my understanding has stalled a little bit in the chemical industry because when we are so engineering focused that we have really great engineering tools anyway, many of the reactors and processes we have in our chemical industry are not modeled to the degree they could be. And it's not because we didn't have the tools to model them, it's because we don't have all the people to do it. So the rate limiting step is resource. And again, back to that nasty little thing, we got to pay our investors. And so we've got to balance our desire for knowledge and all these other things with making sure that our investors get some sort of profit out of this as well, right? So that's something people don't consider. And the digital twin has to, if we involve ourselves in that technology heavily, it has to make money for us. And the money recapture on the expense of doing that is not, at least lately, I'm not aware anybody is terribly clear. So it's cool technology, and there are people looking at it and trying to figure out how to make it work. But I think you'll find that in pockets in companies, but not a overall embrasure of digital twin, simply because I was around when we first started looking at it. Very intriguing, really cool, but in the end, unfortunately, my vice president at the time would keep reminding me, because I was the guy always saying, hey, let's go look at this, let's go look at that, that somehow our investors needed to get some of the cut. And then, by the way, that's an interesting conversation too, is what do you spend money on?
Let's come back to the economics of it, because I think that's a longer conversation, but I do want to touch on that. But just kind of picking up on some of the things that we were just talking about, are there Let's say what innovations has AI and data science enabled that were previously not possible? In other words, were there certain things that you wanted to do maybe in the beginning of your career, but you were constrained by technological limitations?
I don't. It's funny. You don't miss what you don't know. The irony of my the work I did in my graduate career was I found out I had a publication in 2014 I didn't know I had. And how is that possible? Well, my research advisor, there was one project in my dissertation. I told him I couldn't finish because I didn't have the computational capabilities at the time. There were too many atoms. It was too complex back in 1988, 1989. And I said, at some point, the computational technology will get up to the point where we can start doing these calculations. Maybe you can get another student to finish the project. Lo and behold, he did that. It's really cool. So the world of chemometrics allowed us to take the surface of data, the univariate measures, all this data, and start looking at the correlations between those data and picking significant correlations, okay, and realizing we needed to start paying attention to how those those individual data pieces were interacting with each other, how that correlation was moving. And by the way, that was being done in certain online analyzers. It was a normal part of process analyzer technology. But what was really, and that was in 1990, so they already had it. What was weird was nobody stopped to think, if we take the same mathematics and maybe slightly different tools, let's go apply that to the data that's not in the analyzer and see what it tells us. And when my colleague that I brought into this first project was hired in Dow, they wanted him working on analyzers. And I just asked him to use some of his discretionary time to help me apply it to something that wasn't an analyzer, and showed him and everybody else how that application would be very valuable to us. And that's where it started to take off in our company. We immediately started hiring people to come help us do this. So the one thing we all need to be cognizant of, and back to my comment that you need to send people out into industry, into the outward industry to talk to people, we need to be cognizant that the needle's changing, the needle's constantly moving, and there probably is a better mousetrap out there somewhere. But then it's incumbent upon us in the company to go back to our leadership and say, well, I found a better mousetrap, and here's the economic reason why we should try that better mousetrap. That's a really hard discussion. As you said, the economics behind this is probably a completely different discussion with me. But I constantly ran into data problems in the early part of my life, which honestly, chemometrics can solve many of them. You never asked me, by the way, what about the projects where chemometrics didn't solve the problem? And chemometrics didn't solve the problem because we weren't measuring the right things. And in a couple of cases, we did figure out we needed to be measuring something different. And either the univariate measure all of a sudden revealed to us what the problem was, or we started applying our process to that. But chemometrics didn't solve every problem, or AI did not solve every problem. But it's really not because AI didn't do it. It's because AI wasn't given the right information to help us do that.
Do you, and maybe it's unreasonable to ask because we know that you were already working on the bleeding edge of these technologies, right? But how do you see data science evolving in the world of chemicals and in material science?
Oh, it's beautiful.
Is it going to get much better?
It is getting better all the time. I am very impressed with the current generation of tools that are out there. I've spent some time with vendors trying to explain to them that the conversation they need to have with the chemical industry is very different than the conversation they need to have with the insurance industry, for example. And I've also suggested to the vendors in this industry that instead of walking in so impressed about what they can do, they should go out and do a little bit of homework on their targeted key customers, people they really want to work with, and find out what they're already doing. Again, The information's out there if you just look. I get paid to consult with people just to tell them, oh yeah, here's this paper. Here's all the stuff you need to know. How do I get that information? I just know where to look because I have this discipline to go do that. But the technology today is significantly better than it was 10 years ago. I don't think the technology is just taking off at a pace that I've got to keep on it every year. Are you aware of the graphic by Matt Turk at First Capital Investments?
Yeah.
Okay. I don't know if he's still doing that, but he was through the last decade.
Might have run out of page space.
Well, but his graphic, the main issue of his graphic was he shows many of the players in various categories in analytics and data science and the whole digital thread, what they do. And his whole point was, look at the explosion of vendors over this period of time. I was keeping track from like 2014 to 2020, I think, and it was just really exploding. But if you read the articles that he publishes, he says that a couple of key things is the technology is not necessarily changing that fast. The number of vendors, the vendors that he had on the first graphic versus the vendors he had 3 or 4 years later were different because they either changed, they amalgam, they changed their name, but they're just in constant churn. But the one thing that was true was the hype. The hype was constantly going up, even though the industry return on all that hype wasn't there. And there's that graphic that some company advertises. I can't remember, but they have the index of how the hype, and then the well of despair. Do you remember? You've seen this graphic?
Is that the Gartner one?
Yeah, maybe that may be it. So in anything, there's the unmet anticipations, the well of despair as people realize it's not really going to do what it is, and then the general adoption of something somewhere in between where you were and what the hype promised. Okay, and so I would like to think that we're finally getting past all the hype that the term big data and the initial use of artificial intelligence brought. Because I hate the term big data. That's stupid. In the chemical industry, we've been dealing with big data for decades. And to have somebody walk into a conference room with me and say, well, we're experts in big data, you all need help. Oh, come on. You guys never did this to us, by the way, but there are others that did. We know big data, we're impressive. And they didn't have a clue what we were doing in the chemical industry, and what our limitations were, and what our problems were, and why we weren't going to spend $10 million to let 2 of their engineers run around our company trying to help us solve problems. We already got 100 engineers or 1,000 engineers to do that. So I was in a particularly difficult time, and I was trying to get Dow to focus on some things and build its capability when people at the top of the company were constantly getting barraged by these people with these overhyped promises. And I learned I had to go build relationships with other people, with senior executives in Dow that normally I would never have had to talk to, just to explain to them that the hype they are receiving, that's all it is. The people that are talking to them really don't understand what we do, and therefore it's not going to work. Now, by the way, there are some righteous people. I'd like to give you an example. Industry 4.0, you've heard that term. And analytics is a piece of Industry 4.0. Well, there are many other. Industry 4.0 in the chemical industry is defined by each company based on needs. Nobody calls an expert outside in and says, hey, help us with 4.0. If they do, I'd love to get in on that action. But one of the things we determined was we would like more of our devices in our chemical plants talking wirelessly to other devices, because we could improve a lot of decision making this way, get more information out to the people in the field. Well, what do? You look at Wi-Fi. You want plant to plant Wi-Fi, to the edge of the property line Wi-Fi. Well, everybody was promising they could do Wi-Fi. We had a company come in and try it in one of our plants, and I really laud them, because I was skeptical that Wi-Fi would work in a chemical plant. It doesn't work in my house that well, honestly. They went in and set up a bunch of Wi-Fi networks within the plant, And 6 months later, they pulled everything down and walked out and said, sorry, you're right, we can't do this. And really what it is plants, if you want this type of interconnectivity, at least now, I think the technology is you got to put a 4 or 5G system in your plant that's locked into these devices so that you can do this. But that was somebody coming in and promising something, realizing it wasn't going to work and pulling themselves out. We didn't have to kick them out. That doesn't happen very often. And in a world where I want to bring in a data technology into a company, if I have to bring it in and I have to prepare the workforce and I have to get them to use my tool, and there's nobody inside the company that's bought into this and is driving it, I'd say 9 times out of 10, that model is going to fail unless it's a really small company and they don't have those resources and they're willing to pay the vendor the overhead to make sure that that vendor is there and working with them. But it's an interesting concept that the technologies we want to bring in, yes, they will work, but is the workforce going to accept the tool? Is the workforce going to use it? Do they know how to use it? And is there some sort of support mechanism internal to the company to make it happen?
You already, I think, addressed some of what I was thinking about asking you next. Just I was hearing it, but you also had written a really insightful publication about the problems that data and analytics companies face when trying to work with the chemical industry. Again, you've already kind of touched on some of this, but in it, I think you identify 3 main areas. So chemical companies already have internal resources doing much of what vendors have to offer. The ROI isn't as cut and dry as it may be in other industries. And then you were just talking about the Matt Turk effect of the market being so saturated with options that often these big chemical companies tend to tune out and stick with what they have that's already working, right?
Yeah.
Anything else that you can add, and can you explain these challenges and how to overcome them, both from the standpoint of internal resources, but then on the other side, trying to pursue innovation efforts and in the vendors who are trying to help. So not just the vendors themselves, but also somebody like yourself. If you're at a different company and you're trying to pursue these, how can you overcome these kind of challenges?
So other than the things we've already mentioned, I won't try to hit those again. The companies that I think I advised in one of the documents you read that there are 3 kinds of companies out there. There's the really large megalithic company that already has most of these capabilities internal. They may be kludgy, but as you already pointed out, if it ain't broke, why fix it? That I had a real hard time fighting that. Fortunately, I bring some things in we just simply weren't doing and prove their value. They're medium-sized companies that they have the sophistication to know that they need something. They don't have the critical mass to make it happen internally. And for vendor companies, that's a sweet spot in my mind. And then there's some companies that are so small, they either don't know they need it or they can't afford it. Okay. And it's really incumbent upon the vendor to start to segment their client list based on this. You still should go after the big accounts and the really small ones, but I think the meat of who's going to be paying you generally would be those mid-sized companies that really appreciate the support you're giving them, but don't have that critical mass internally. The culture is, what is it? Culture eats strategy for breakfast. Is that the quote?
Sounds right.
And what I had the hardest time dealing with in my company was the engineering culture. I didn't like the fact that so few actual chemists, and by chemists I mean people who understood kinetics, rate of reactions, the thermodynamics of what was going on in the processes, were so uninvolved in our plants. I would tell our young engineers that if they really wanted to get ahead in my company, and by the way, if a young engineer is watching this story and you're just brand new in your company and they have just given you all these little books or all these videos, or they've sat you in a conference room for months to teach you how a plant works, this piece of advice: go mass balance your plant. Now, why would you mass balance a plant? because that forces you to think about the engineering and the chemistry of the plant. It forces you to ask questions about how the plant was designed and is it meeting that design criteria? And if it's not meeting that design criteria, is that because it can't or it's not being allowed to? But in the end, you end up becoming more conversant across the chemistry and the engineering of the plant. The problem with the great AI tools we have today is that people are segmented in these two areas. And I'm sorry, you can't ignore the chemistry and you can't ignore the engineering. It all has to come together. So therefore, my most successful collaborations came from a melding of those two. If I were to go start a chemical plant today, the first thing I would do is go hire engineers out of some pulp paper plants in Louisiana, Mississippi, and Tennessee. And you would ask, why on earth, Lloyd, would you want to hire those people? Because I know those engineers understand how the pulp plant works. They're required to run the plant. They're required to fix the online analyzers that are with the plant. That experience, because they run on a very thin margin, right? They're making paper. Those engineers have such a broad experience. Their plant experience is like my graduate experience, and they come out of there with an understanding that no engineer fresh out of school into a mainstream Cadillac chemistry plant could ever have. And they are the ones that come out with an appreciation of AI, honestly, of what it can do, because they have physically experienced the aha moment when doing a simple computation with some of the tools that you provide and others provide allowed them insight into a behavior that was vexing them and caused them to solve a problem. And in large chemical companies with lots of resources, everybody's got a little piece to play in this, and that overarching aha about how this whole thing works, the generalist, as I talked about earlier, is missing. And if you don't, so the generalists are more excited about AI technology than the specialist, because the specialist says, hey, I've got my tool, I'm doing what I'm doing. The generalist goes, well, but I'd like to take what you got and what they've got and bring it all together and understand how the place is operating. And that is back to a company culture, the not invented here syndrome, which we all have to deal with. And I think that the industry is making great inroads. I see it. But another thing I haven't really talked about here is that the habits of the 90s are still working today in 2023. The culture of the 90s and the 80s is still here. It's retiring, but it's still here. And I think that as new generations come into the chemical industry and bring the tools that universities are now offering them through collaborations with vendors and other people, the growth in what is currently being offered will rise. And I hope to see that improvement in the chemical industry in the next 10 years.